Each of these three pictures here represents a different type of pyramid, and the type of pyramid is determined by the base. So in this case over here, we have either a square or a rectangular base. This one's square, and each of the triangles, when you have a square base, are going to be equal. So for finding the surface area of this one, each triangle would be equal. In this next pyramid, the base is a triangle, so it would have three sides. If this was an equilateral triangle, all three of the sides would be equal. If it was an isosceles triangle, two of the sides would be equal with a different size for the third one. And this third pyramid is a hexagon base, and if the hexagon is a regular hexagon, then all six of the triangles would be the same size. So in order to find the volume of each of these, we start with the same formula, and it's volume equals 1/3. And then for the base, we'll use the Greek letter B for beta. It's a capital B. And then what we're looking for is the height of the triangle. Let me just take a second here to show there's two different types of heights here. The height for the one that's inside is showing the height of the pyramid, but this line over here, which is a height, is called a slant height. And the slant height is there for us to find the surface area because we would need to know the height of the side triangle in order to find its area. In the case of this one, since it's a square, it's 1/3. Beta is the area of a square, so that's base times height. And then for the height inside here, instead of this h here, we'll use a d for depth. So on the next one, it's volume equals 1/3 beta, and we'll use depth here. And then since it's a triangle for the base, beta is going to be 1/2 base times height, and we bring down the d. And then for this last one, it's the same thing. I have volume equals 1/3 beta depth. Now, if you're in 6th or 7th grade and you're learning how to find the volume of a pyramid, they would indicate what the area is for the hexagon here. But for high school students, the volume of a hexagonal pyramid would use square root of 3/2 times b squared times depth, or the height of the pyramid. So in finding the volume of this pyramid over here, which has a square base, we'll replace beta with base times height. And we'll bring down the d. So for the purposes of the depth here, our depth is the height of the pyramid is 12 feet. We're not using the slant height until we do surface area, which is next. So now I'll just substitute all of these values into the formula. So I have 1/3. The base is 10. The height is 10, and the depth, or the height of the pyramid, is 12. Now before we start, if we're able to get rid of this 1/3, we should do it now. So 1/3 of 12 is 4. So now we just multiply. So 10 times 10 is 100, times 4 is 400. So our volume is 400 feet cubed. So now to find the surface area, I need to find the area of the base first, and the area of the base is just 10 times 10, or 100, so we'll write that in here. And it's going to be feet squared. And then for each of the triangles, since each of these sides here is going to be 10 for the base, and then the triangle's height is going to be the slant height in here is 13. So area equals 1/2, the base of 10, and the height of 13. I'm going to get rid of the half first, so half of 10 is 5. And 5 times 13 is 65 feet squared. And this is going to be the same for all of the triangles. So this is 65, 65, 65, and finally 65. And then for the surface area, we just add these all up. So we get 260 plus 100. So the surface area is 360. And surface area is area, so it's feet squared. Moving on to find the volume of a triangular pyramid, we see that this base is not an equilateral or isosceles, but rather a 3, 4, 5 right triangle. So all three of the sides at the top are going to be different. And we can find the volume of this, but we can't find the surface area because we don't know the slant height of the three side triangles. So to find the volume, we start with the generic formula for the volume of a pyramid, which is 1/3 beta depth. In this case, beta is a triangle, so we're going to put inside 1/2 base times height, and we're going to bring down that d. So substituting, we have 1/3 times 1/2. Now the base of the triangle, we'll use 3 and 4, so I have 3 times 4, and then this d is the height of the pyramid, which is also 4. So I'm taking half of one of the 4's is 2, 3 times 2 is 6, times 4 is 24. I need 1/3 of 24, which is 8 miles cubed. Here we're given a regular triangular pyramid where each of the sides here at the bottom are equal. So we're going to be able to find the surface area of this. We're going to open this up into a net. And we see from the net we have 3 equal triangles. This is equilateral at the bottom. So each of these sides is going to be the same, and they're all 10. And then we're given the slant height, which allows us to find the surface area, and that's 14. So finding the area of each of these triangles, we have area equals 1/2 base times height, which is 1/2. The base is 10. The height is 14. We'll take half of 14, which is 7. So we get 70 meters squared. So this is 70. Change color. This is 70, this is 70, and this is 70. And then finally, for this triangle here, we're given that the height is 8.7. So for the second one, we'll do area equals 1/2 base times height. So it's 1/2. We're given that the base is 10 and the height is 8.7. So half of 10 is 5. And 5 times 8.7 is 43.5. And this is meters squared, so we can write the 43.5 here. And then for the surface area, we simply add up all of these. So we get 70 times 3 is 210. And 210 plus 43.5 is 253.5 meters squared. This pyramid, we see that it has a base that is a hexagon. And instead of giving us any of the dimensions for the hexagon to find its area, they're just giving the area here. This is supposed to be our beta. So we just start with the generic formula, which is volume equals 1/3 times the area of the base, which is beta, times the depth. So I bring down the 1/3. We are given that it's 48 here for the area of the base, and the height is 9. So we can take 1/3 of 48 is 16 times 9. And 16 times 9 is 144. And for our units, we have millimeters cubed. Here we have a regular hexagon pyramid. All the sides are equal. And we're not going to draw the net for this one. We'll do it differently. So to find the surface area, I'm going to find the area of the 6 triangles. So it's going to be 6 times 1/2 base times height. The base of each triangle is 7, and the height of each triangle is 10. This is half of 70, so this is 6 times 35, which is going to equal 210, and our units are centimeters squared. Now for the hexagon, do it over here. Now for the hexagon area, without knowing the formula, the way that I remember my 6th grade teacher was trying to get us to figure out how to find the area of some shapes without giving us a formula. And what this is 6 equal triangles again. So it's 6 times 1/2 base times height. So this will become 6 times, keep the 1/2. The base of each triangle will be 7, and the height of each triangle is 5.5. So half of 7 is 3.5. So 3.5 times 5.5 is 19.25, and 6 times 19.25 is 115.5. And then for our total surface area, we just add these together, so we get 325.5 centimeters squared.